أعوذ بالله من الشيطان الرجيم بسم الله الرحمن الرحيم. Dear student, Assalamu alaikum. Today our lecture is regarding class 9 subject physics. Today we are going to start new chapter, chapter number 8. The name of the chapter is Thermal Properties of Matter. This is a new chapter as we have finished chapter number 7. Now we are on chapter number 8. The name of the chapter is Thermal Properties of Matter. Topic of today's lecture will be 8.1 and 8.2. These two topics are on page number 169, 170, 71, and 72. We will try to cover these pages and I start the topic 8.1, 169. Please open 9th class textbook page number 169. This is the chapter, unit number 8, thermal properties of matter. Name of the chapter is Thermal Properties of Matter, and the chapter is 8, unit number 8. Please open page 169. 169, please open the page. As this chapter, we are going to start topic 8.1, temperature and heat. The name of the topic is temperature and heat. First of all, I will tell you about the temperature, and then afterwards, I will introduce you with the heat. First of all, temperature and then heat. Okay. When you might have seen when we touch a body, we feel it hot or cold. Whether the body is hot or whether the body is cold, either the body is hot or either the body is cold, we feel it. When we touch the body, if you touch the hot pot, you see how much hot it is. But the temperature is defined as, this is the definition of the temperature. Temperature of a body is a degree of hotness or coldness of the body is called temperature. This definition is the definition of the temperature. We will try to understand this temperature of body is the degree of hotness or coldness of the body is called temperature. You might observe that when a candle flame is hot and is said to be at high temperature. When you lit a candle, when you put your hand over the candle, you feel it hot. So it means its temperature is high. But on the other hand, if you touch the ice, it is cold because it is at low temperature. Candle is at high temperature and ice is on a low temperature. How did we examine this is hot and this is cold? Because of our sense of touch is telling us whether the body is hot or whether the body is cold. When you when you place your hand over the candle flame, you feel it hot. Your sense of touch will feel it hot, and when you touch your hand over the ice, you will feel it cold. The reason behind it, your sense of touch tells you how much hot or cold the body is. So temperature is, that's why temperature is defined as the degree of hotness or coldness of body. Coldness of body. This temperature sense is somewhat approximation and unreliable because it is not practicable to touch every body, even it is very at high temperature, because they are at not very much high temperature. But when you place your hand over the candle flame, you immediately remove your hand. But it will tell you how hot the body is. But it is not practicable. It is not practicable to touch every body, and this is not a reliable source to touching the body. To use a sense of touch, so we use other methods to determine how the hot or cold the body is. Before understanding this temperature concept, we will try to understand two more terms, that is called thermal contact and the thermal equilibrium. These two terms are very important: thermal contact and thermal equilibrium. I'm trying to explain you right now. To store ice in the summer, people use it with cloth or keep it in wooden box or in the thermoflask. What will happen? You might have seen in summer when they want to store the ice, They either the people wrap it in a cloth, or they store in a wooden box, or they put it in the thermos flask to store the ice. Otherwise, why they put it, wrap it, or store it in a wooden box or thermos flask? The reason behind it, they want to, um, in this way, they avoid the thermal contact of ice with its the hot surroundings. They want to, because they don't want to expose the ice over the heat or sun. Otherwise, the ice will melt down. If they make contact with the surroundings, the ice will melt down quickly. That's why the reason behind, in summer people use thermoflask or wrap it in a cloth, or or wooden box to store the ice, to keep the to avoid the ice quickly melt down. So this is the concept of thermal contact, right? Similarly, when you place a cup of tea or water in a room, it cools down gradually. You might have seen that when you take the hot cup of tea, and the temperature, suppose that the room temperature is 22 degrees, and your hot temperature, the temperature of the hot tea is about 70 degrees Celsius. What will happen after some time? You might have observed that the temperature of the hot cup of tea uh, comes down to the room temperature. It cools down. The reason behind it, it is releasing its energy. Heat always transfers from the hot body to the cold body. The temperature of the cup of tea is hot, and the temperature of room temperature is at low temperature. So, from heat is going to be transferred from hot body to the cold body, and keep on transferring until both have the same temperature. Both mean the temperature of the cup and the temperature of the hot tea and the surrounding temperature, when becomes at the same temperature, the heat will start flowing. This type of thing is called thermal equilibrium. Equilibrium means, so if you have a little bit difference, for example, the cup of tea has a temperature is 30 degrees Celsius, and our room temperature is 22 degrees Celsius. There is a difference of temperature. So one body is at hot, little bit hot, and other body is at 22 degrees Celsius. Where the heat will start flowing, the heat will start flowing from hot body to the cold body, from the cup of tea to the room temperature, and after some time, it both have both temperature of the cup of tea and room are the same temperature. Heat will keep on transferring from hot body to the cold body when they have at the same temperatures. So this is the concept of thermal equilibrium. Thermal equilibrium means when both the bodies have the same temperature. Now we understand the what happens when we touch a hot body. The two bodies having different temperatures, bring them in contact with each other. Bring them in contact with each other means place them with each other, place side by side with each other. So bring them in a contact with each other. The temperature of the hot body falls. You might have seen the temperature of the hot body will fall down, and it will transfer. This heat will transfer to the cold body. The temperature of the hot body falls. It loses energy. The energy enters the cold body at low temperature. So the transfer of energy continues till both the bodies have the same temperature. For example, I take another example. If one person, there is a cold outside, the cold weather is outside, and one person is sitting in his room. He is at a different temperature. The person who is sitting in that room have different temperature. The person who is coming out coming out of out, he has different temperatures. One is at cold temperature and one is at hot temperature. So what will happen when they shake hands with each other? What will happen? The heat will going to be transferred from uh, hot body to the cold body, until and keep on transferring if they have at the both temperatures. The hot body and the cold body will at the same temperature. So if it is a little bit difference of temperature, the heat will always transfer from hot body to the cold body. As I told you, there are the two persons, one is coming out and one is inside the room. When they shake hand, they have the different temperatures. One is, suppose one is one's hand is 20 degrees Celsius and the other hand is 14 degrees Celsius. So he one is at higher temperature 20 degrees Celsius and one is at 14 degrees Celsius lower temperature. What will happen if they shake hand with each other? The heat will keep on transferring from 20 degrees Celsius to the 14 degrees Celsius. When they are in contact, when they are keep on handshaking, the heat will always transfer from hot body to the cold body and keep on transferring when they have at the both the temperature, both the body has the same temperatures. So the this in this definition, heat is energy that is transferred from body to the other in thermal contact each other and result of the difference of temperature between them. This is the definition of the heat. Heat is energy that is transferred from one body to other in thermal contact with each other as a result of difference of temperature between them. As I told you, the examples of shaking hand. One is at 20 degrees Celsius and one is at 14 degrees Celsius. Suppose so, the heat will transfer from hot body to the cold body in thermal contact with each other as a result of difference of temperature between them. Because one body temperature is 20 degrees Celsius and another body temperature is 14 degrees Celsius. So there is a difference of temperature. So this is the definition of the heat, and this is the definition of the temperature. Now I move towards what is internal energy. The sum of kinetic energy and the potential energy associated with the atoms, molecules, and particles of the body is called its internal energy. Heat is therefore called energy in transit. Once that enters the body, it once that it enters the body, it becomes the internal energy and no longer exists as a heat energy. So when the people shake hands with each other, one is at high temperature and one is at the lower temperature, the heat will start transferring from hot body to the cold body until it both has the same temperature. When they are at the both temperatures, the one body will lose energy and other body will gain energy. Cold body will gain energy and hot body will lose energy. So it will becomes the part of the cold body. When it will transfer from hot body to cold body, it will become the part of the cold body. In cold body, this is called the internal energy. So internal energy is the sum of kinetic energy and potential energy associated with the atoms, molecules, and particles of the body is called internal energy. Internal energy fact is depending upon some factors. Internal energy of a body depends on many factors such as the mass of the body, kinetic and potential energies of the molecules. So internal energy of a body depends on mass of the body. Greater the mass, greater will be the internal energy. Smaller the mass, smaller will be the internal energy. It is also depending upon the kinetic energy and potential energy of the molecule. So if we heat the water, so water contains molecules and atoms. So when we heat it, its kinetic energy becomes increased. So our internal energy also depending upon the mass of the body, and it is also depending on the kinetic energy and potential energy of the molecules. Now, this is the end of the topic 8.1, in which we discussed about temperature, and I gave you the example how we check the temperature. But it is with a sense of touch, but it is not reliable because to check the temperature of the body, if it is more hot, then your hand could be burned. So it is not a reliable method to check. But if it is a little bit temperature, then you can test with the help of your touch sense. But it is not a reliable method. So then we can study about the thermal contact and thermal equilibrium. And then I gave you the examples of thermal contact and thermal equilibrium. And then we discussed what is heat. Heat is always transferred from hot body to the cold body when they are in thermal contact with each other as a result of difference of temperature between them. Then we studied about kinetic energy. the sum of kinetic energy and potential energy associated with the atoms, molecules, and particles of the body is called internal energy. This is the definition of the internal energy. And then we discuss about on which factors internal energy is depending upon. Internal energy is depending upon mass of the body, kinetic and potential energy of the molecules. So this is the end of the topic 8.1. Now I'm going to start topic 8.2. The 8.2 topic is thermometer. What is thermometer? Thermometer will tell us how hot or cold the body is. In order to determine the measure the temperature of the body, we use the device which is called thermometer. You might have seen at your home thermometer, mercury thermometer, clinical thermometer, mercury thermometer we use at home to check the body's temperature. So the thermometer is a device which is used to measure the temperature of a body is called thermometer. If they ask you in the exam what is thermometer, define thermometer, so you will write from here a device that is used to measure the temperature of a body is called thermometer. So this is the definition of the thermometer. Device that is used to measure the temperature of a body is called thermometer. So thermometer determines how hot or cold the body is. When it is placed in the hot body, it will tell you the temperature will go and rise. But if it is placed in a cold body, it will tell you the temperature of the body. So thermometer is a device basically it is used to measure the temperature of the body. Some substances have property that changes with temperature. Substances that show the change with temperature can be used as a thermometric material. So you might have seen when they designed the thermometer, they put the mercury in it because mercury is a thermometric material. Why it is used as a thermometric material? Because it changes with the change of temperature. If we increase the temperature, that it will change with the change of temperature. The substance that shows change, that's why he is using saying substance that show a change with temperature can be used as a thermometric material. So in um, in thermometer they use mercury because it changes with the change of temperature. That is called a thermometric material. So mercury is the thermometric material. Some change their color. Some thermometric material change their color. Some change their electric resistance. Nearly all the substances expand on heating. Liquid also expand on heating and are suitable for thermometric material. Liquids are also expand on heating and are suitable as thermometric material. Common thermometers are usually used some suitable liquids such as thermometric material. A thermometric material liquid should have the following properties. The material which we want to use as a thermometer, in the thermometer, it should have following properties because we are using mercury in the thermometer that has the properties of thermometric material. The properties of the thermometric material they should be visible because you can see the mercury going up and down when it is placed in the body in order to measure the body's temperature. We place the thermometer inside the body. So under the arm, you put your thermometer, or the doctor put the thermometer under your arm or under your tongue to measure the body's temperature. So what will happen when they place the thermometer under your tongue? The key, the mercury is using in the thermometer. It changes with the change of temperature. So it has a falling property. So mercury must have falling properties. It should be visible because you can see easily the mercury. It should have uniform thermal expansion. It is not changing abruptly, it is changing gradually. It will go to 10 degrees, then 11 degrees, 12 degrees, like this, 37 degrees, then 38 degrees, 39. It has the uniform thermal expansion. It does not change quickly. Suppose if body temperature is 37, it is not like this. It will go to 46 degrees Celsius or abruptly change. So it has a uniform thermal expansion. That's why we are using mercury in a thermometer. It should have a low freezing point. Mercury has a low freezing point. Whatever the material, the thermometric material, it should have these properties. It should be visible. We can see this. If we cannot see this cannot be used in the thermometer. So mercury is visible. You can see it very clearly. It should have uniform thermal expansion. It should have a low freezing point. It should have a high boiling point. So mercury, while freezing point is low and mercury boiling point is high. It should not wet glass. It should be good conductor of heat. It should have a small specific heat capacity. I will tell you what is small specific heat capacity when we study the specific heat capacity. But you should know in order to thermometric material, this thermometric material must possess these properties. It should be visible. So our mercury is the thermometric material we use in the thermometers. So what is the properties of mercury? It should be, you can see it. It has uniform thermal expansion. Its boiling point and its freezing point is low. Its boiling point is high. It's not wet glass. It is a good conductor of heat. We can pass through it. It should have a small specific heat capacity. These are the properties mercury possesses. That's why we use it in the thermometer. As I show you now, this black color, this is the thermometer, glass thermometer. Mercury is used in it. This one is the mercury. So mercury thread, you can see this is the mercury thread. This one where my cursor is pointing, this is the mercury thread. So this is the thermometer scale. So thermometer has 10, 20, 30, 40 scale on it. So it is going to 100. Then it is onward going on to 105, 100. So this is 90, this is 100, this is 110, this is 120. So 10, 10 gaps. So 0, 10, 20, 30, 40, 50, 60, 70, 80, 90, 20, 90, then 100, then 110, 110 and 120. So its mark over here is 20 degrees Celsius. Mark here. So what is so mercury, we use mercury in the thermometer because mercury is visible. Mercury possesses the following property. This it is visible. It should have uniform thermal expansion. It has a low freezing point. It has a high boiling point. It should not be a wet glass. It should be a good conductor of heat. It should have a small heat capacity. That's why we use mercury in the thermometer. So this is the thermometer. So this brown line shows this is the mercury, because whenever it is placed under the arm or under the tongue, it changes with the change of temperature. It sends your body's temperature and it will rise up. If your body is hot, then it will show you more temperature. The mercury will goes up, right? And if the body has less temperature, then the mercury will go down. Okay. So the thermometer is used. Mercury is used in the thermometer. So mercury possesses the following property as I discussed. A liquid gas thermometer has a bulb, so it is a bulb over here, right? With a long vertical capillary tube of uniform and fine bore such as shown figure. You can see this one is a thermometer. A suitable liquid is filled in the bulb when the bulb contacts a hot object. So we place this bulb under our arm or under our tongue. So this bulb is placed when the bulbs contact a hot object, the liquid in it expands, the mercury expands and rises in the tube. So as I have already told you, the mercury will expand. The glass stem of the thermometer is thick and acts as a cylindrical lens. So this makes it easy to see the liquid level in the glass tube. So it is the transparent, so you can see the when the mercury is expanding, you can and it stops when it will sense the temperature will stop, and you can note the reading in Celsius. Suppose this mercury level stops over here, so you can see the temperature is 60 degrees. But if it is stops over here, you can see the temperature is 90 degrees. If it is stops between this is 37, 36 degrees Celsius. So wherever the mercury will stop, you can read from this because you can clearly see because this is placed in the glass, so you can easily see the column of the mercury. Mercury has as I told you, mercury has a low boiling point, so its the melting point is minus 39 degrees Celsius, and its boiling point is very high. You can see this. Its freezing point is minus 39 degrees Celsius. The mercury freezes at minus 39 degrees Celsius, and while that is 157 degrees Celsius. So I have told you the thermometric material. Mercury is used as a, in the thermometer is as a thermometric material, so it has a low freezing point and high boiling point. It has all thermometric properties listed above, as I explained you lastly. This one I have explained you. So mercury explained all the thermometric properties. Thus, mercury is one of the most suitable thermometric materials. Mercury in a glass thermometer are widely used in the laboratories, clinics, and houses to measure the temperature in the range from minus 10 degrees Celsius to 150 degrees Celsius. So we can doctor use in their clinics, in the laboratories, use these type of mercury thermometers. So they can range the temperature, measure the temperature from ranging from minus 10 degrees Celsius to 150 degrees Celsius. Okay. There is a lower and upper fixed points. A thermometer has a scale in the stem. You can see the scale. This is a scale 0, 10, 20, 30, 0, 10, 20, 20, 30, 40. This is the scale on its stem. This scale has two fixed points. The lower fixed point is marked to show the position of the liquid in the thermometer when it is placed in the ice. When you place this in the ice, the temperature will go decrease, so it will less than 0 degrees Celsius. This is the lower fixed point, and it is the upper fixed point when it is go up. When the mercury is go up, it is the upper fixed point. So upper fixed point is a mark to show the position of the liquid in the thermometer when it is placed in the steam. Suppose you put this thermometer into the steam, so it will show you the mercury column will stop at. For example, if you place it in the hot water, so boiling point will show you, it will tell you the boiling point of the water, and you know the boiling point of water is 100 degrees Celsius, and then our mercury will stop over here. So it means this is the upper fixed point, and where when you place this thermometer in the ice, it will show you 0 degrees Celsius, so it is the lower fixed point. So scales of thermometers, scale is marked on thermometer. The temperature of the body in contact with the temperature can be read on that scale. Three scales are normally used. One is called Celsius scale, or other word is called centigrade scale. One other one is called Fahrenheit scale and Kelvin scale. So doctor use basically Celsius and Fahrenheit. So in the doctor clinical thermometer, doctor has on one side you can see the Celsius, and other side is Kelvin. But in this example, they show you Fahrenheit, Kelvin, and Celsius, and differently they place in differently. So here we have Celsius scale, and then Fahrenheit, and then Kelvin scale. So doctor basically use Celsius and Fahrenheit to measure your body temperature. So we will see, firstly we discuss Celsius scale. The interval between lower and upper fixed point is divided into 100 equal parts. So it's basically lower fixed point is 0 degrees Celsius, and upper fixed point is 100 degrees Celsius. So it is divided into 100 equal parts. I'm talking about Celsius scale. On Celsius scale, lower fixed point is 0 degrees Celsius, and upper fixed point is 100 degrees Celsius. So it is divided into 100 equal parts. So this is our Celsius scale. So he is saying upper fixed point is divided into 100 equal parts as shown in figure 8.5. The lower fixed point is marked as 0 degrees Celsius, and upper fixed point is marked as 100 degrees Celsius. So basically Celsius scale is divided into 100 equal parts, and it has two divides. Lower fixed point is 0 degrees Celsius, and upper fixed point is 100 degrees Celsius. I am talking about Celsius scale. Now I am talking about Fahrenheit scale. On Fahrenheit scale, the interval between lower and upper fixed point is divided into 100 equal parts. So this scale is divided into 180 parts, but Celsius scale is divided into 100 equal parts, but Fahrenheit scale is divided into 180 equal parts. Its lower fixed point is marked at 32 degrees. So this lower fixed point is marked at 32 degrees Celsius, and upper fixed point is marked as 212. So if you subtract 212 minus 32 degrees, you will get 180 equal parts. So our Fahrenheit scale, the lower fixed point is marked as 32 degrees Fahrenheit and upper fixed point is marked as 212 degrees Celsius. If you subtract 232 from 212 degrees Celsius, you will get 180 equal parts. So Fahrenheit scale is divided at 180 equal parts. Now I'm talking about Kelvin, and you know the unit of temperature is Kelvin. SI unit of temperature is Kelvin, and Kelvin is the name of the scientist. In SI unit, the unit of temperature is Kelvin, and its scale is called Kelvin scale of temperature. As in shown in figure 8.51. It is 8.5a, it is 8.5b, it is 8.5c. This figure is 8.5a, this figure is 8.5b, and this figure is 8.5c. The interval between the lower and the upper fixed point is divided into 100 equal parts. As you can see in Celsius, I told you the lower fixed point is 0 degrees Celsius and upper fixed point is 100 degrees Celsius. This is divided into 100 equal parts. Similarly, in Kelvin scale, this is also divided into 100 equal parts. The lower fixed point is 200. The lower fixed point is 273 Kelvin and upper fixed point is 373 Kelvin. If you subtract 273 from 373 Kelvin, you will get the Kelvin scale is divided into 100 equal parts like Celsius scale. Celsius and Kelvin scales are divided into 100 equal parts. So our Fahrenheit scale is divided into 100. Fahrenheit scale is 180. It divided into 180 equal parts, but our Celsius scale and Kelvin scale are divided into 100 equal parts. But the only difference is here the fixed point, lower fixed point is 0 degrees Celsius and upper fixed point is 100 degrees Celsius. But here the lower fixed point Kelvin scale, lower fixed point is 273 and upper fixed point is 373 Kelvin. So if you subtract 273 from 373, you will get 100 equal parts. So this is the end of the topic, today's topic, in which we discussed about thermometer and we discussed about temperature and heat. We saw the difference between temperature and heat, and then we discussed about thermometers, and these are the properties of the thermometric material. This is the properties. These are all the properties of mercury. Mercury possesses all these properties. It should be visible. It should have uniform thermal expansion. These are the properties of thermometric material. Then we discussed about thermometer. What is thermometer? Thermometer is a device to measure the temperature of the body. It will tell you how hot the body. Then we discuss about the lower and upper fixed points. Then we discuss about the scales, Celsius scale, Fahrenheit scale, and Kelvin scale. This is divided into 100 equal parts. Celsius scale is divided into 100 equal parts. Kelvin scale is divided into 100 equal parts, and Fahrenheit scale is divided into 180 equal parts. So there are basically three scales: Celsius scale, which is also called centigrade scale, Fahrenheit scale, and then Kelvin scale. But doctor use both the Celsius and Fahrenheit scale. So this is the end of the topic, today's topic. If you still have any questions regarding today's topic, please feel free to ask questions. So our homework will be memorize the topic covered in today's lecture and write down one summary of it. So this is for your practice. So memorize them, the definition of heat and temperature, internal energy. These are the definitions you need to memorize them, and then you need to write, memorize the topic we covered about the temperature thermometer. So it is divided into Celsius, Fahrenheit, Kelvin. You need to memorize them. So this is your homework. If you still have any questions regarding today's lecture, please feel free to ask questions. Thank you. Mizna, do you have any question regarding today's lecture? Please ask question.